Hi. How you doing?
Good.
This is what, the 16th already? My goodness, bless you. And y'all are my very wonderful, ready to go home 8th period class. So we're talking about pyramids and cones. Y'all know what a pyramid is, yes? Like the great pyramids in Egypt? Yeah?
Yes.
Like that. It's a pyramid that has one flat polygon as a base, and then the walls all come up to a single point. And all of those walls are triangles. So this is a drawing of a pyramid. All right. This point right here is called the vertex. The shape down here is the base face. I have a slant height. That's the new one. So if I look at one of those triangle walls, and I think of it as just a triangle, it has a height, this triangle. This is the slant height. We're going to use the lowercase cursive letter L for slant height. Okay? That's the height of one of the slanted walls. The actual height is in here. And it goes from the vertex toward the base face at a 90-degree angle. Okay? All right. Let's get to the formulas. Oh, let's fill in our paragraph here. A pyramid, let's spell it right, there it is. A pyramid, it's a solid with a polygon base, so you could have a triangle pyramid, you could have a square pyramid, a rectangle pyramid, an octagon pyramid, and we add a little syllable in there to make it descriptive, so we have like an octagonal pyramid, a rectangular pyramid. A pentagon base would be a pentagonal pyramid. Okay? So it just changes the pronunciation. For a regular pyramid, regular pyramid has as its base some sort of regular polygon. And the lateral edges, that is where two of those side walls come together, the lateral edge, all of the lateral edges are congruent. All of the lateral faces are congruent isosceles triangles. What was an isosceles triangle? Okay, that has how many sides equal? Two. Triangle with two congruent sides. The height of each of these lateral faces is that slant height that we were talking about. Let's handle our formulas. Like the prisms and the cylinders from yesterday, we have two areas. We have one area for the lateral. Where? Which word? Here? Slant height. Like how tall something is. Height. Thank you. So we have two formulas. We have a formula for the lateral surface area, and we have a formula for the total surface area. They look like this. Lateral surface area is 1/2 times perimeter times slant height. Okay? I'm trying to make this look like a cursive-y lowercase l because I don't want it to look like the number 1. And I don't want to use a capital L because I'm using that for lateral area. Okay? So here's L, the slant height. And here's P, the perimeter of the base. the formula for the total surface area is going to be the lateral surface area plus, what did B stand for? The area of the base face. Let's play with these formulas. I have 4 shapes. Which one would you like to see first?
4 shapes.
I have 4 shapes at the very bottom of the page. Which shape would you like to see? Number 4, okay. Start off with the pentagon, huh? All right, yeah, I love it. Here we go, scrolling down to number 4. There's my shape. All right, let's figure out what parts we have. What kind of line is this?
Equilateral.
That would be a kind of shape. We're talking about that line. What kind of line is that? Is that a height? Is that a slant height? Is that a side? It's a slant height. So that's going to be L. What about this line right in here? What's that? It's our, yeah, it's a base edge. And it's a base edge, so it's one of the sides of the base. Here's our measurement. We're going to use this to help us find the perimeter. So then the last line that's in here that looks kind of crazy is this one right here. It seems to come from the very center of my polygon, go toward an edge, and hit the edge at a 90-degree angle. What kind of line does that? It's related to the radius. It is on the base. It's the apothem. The apothem is the line that goes from the center of a regular polygon out to one of the sides at a 90-degree angle. This is the apothem. All right, that's all the information we've been given. Let's go into our formula and see if we need to find any more. What's the formula for the lateral surface area of a pyramid? 1/2 times the perimeter times the slant height. All right, what's the perimeter? How many edges does the base face have? 5. And each edge is?
8.7.
All right, so 8.7 times 5 gives you the perimeter. Go ahead. What was it? 43.5, she says. Confirm it. I got a thumbs up. Did you confirm it? I really would like you pushing the buttons on these pieces. Thank you. What was the measure of the slant height? 15, right here. Okay, put that in the calculator. Tell me, what is the lateral surface area of this figure?
326.25.
Bless you. We want to round this to the nearest tenth. So, this is my 10th decimal place. I'm going to look at this number. Is that number bigger than 4? Yes. And so I'm going to round up. What was it? 0.3. Oh, dyslexic moment, sorry. Lateral surface area, done. Let's find the total surface area. What's the formula for total surface area?
Lateral area plus the base.
The lateral surface area plus the area of the base face. Okay, what was the lateral surface area? 326.3. We calculated that in our previous step. Now we need the base, the area of the base. The base is a regular pentagon. So what is the formula for the area of a regular pentagon? Going back to your formula charts, find the formula for area of a regular polygon.
1/2 times area.
Times the little a, apothegm.
Times perimeter.
Beautiful. Do I have a value for the apothegm?
32.
Look back at your figure. Did they give me an apothegm?
No.
Yes.
Yes. They did. It was 6. P is the perimeter of the base. Didn't we already calculate the perimeter of the base?
Yes.
There it is. So I'm just going to fill that in. All right, put that in your calculator. Tell me the value.
$130.5.
130.5. And so the total surface area of this pyramid is
456.
and we're done. Questions? Do you want to see another one? Which one? I think number 1 is a little hard. You want to see number 1? You want to see number 2? Number 1. Okay. You want to see number 1 or number 2? Number 1? Okay. So here's number 1. What shape is the base?
Triangle.
It's a regular triangle. Okay. So it's a regular triangle. I'm going to draw that regular triangle right here. Here's my regular triangle. I drew it big. I need information about this triangle because I know I'm going to have to find its area. Yes? All right, so let's find its area so we can get that out of the way. So the area formula for a triangle is 1/2 the base times the height. This is the base of that particular triangle, and it's 15. I want next the height. This is the height,
20 centimeters.
right there.
20 centimeters.
How do you know it's 20?
It's a 1.
Okay, this height here is different from this height here.
That's 1 height.
The slant height is not sitting on the base. So I need the height of the base face of the floor. I need this one. Now this particular line, this height, cuts the base edge into 2 equal pieces. If the total base was 15, how much is one of these little edges? Half of 15. Yeah, 7.5 right here. Okay, so now I have this right triangle. 7.5 here, 15 here. I want to find the height. What can I use in right triangles to help me find side lengths? The 90-degree angle tells us it's a right triangle. It's what helps us use these. We've got a couple different options. We can use the Pythagorean Theorem. A squared plus b squared equals c squared. We could use trigonometry. But in order to have trigonometry, we need angle measures. Do we know angle measures? No. Could I find them?
Yes.
Maybe. But I've got the stuff for Pythagorean Theorem, so, like, that's might be an easier. I don't know. If trig's easier for you, use the trig. If this ends up being a special right triangle, this little piece right here, if this ends up being a special right triangle, either a 45, 45, 90 or a 30, 60, 90, you could use those as well if that's faster for you. Using the Pythagorean Theorem, what's my setup? Which one's A? 7.5. Did you want to say H, someone? For A? If you wanted to say H was A, you're right. It could be A also. So then what's C? Solve it for each. Square 7.5, you get
56.25.
56.5?
25.
25. Shh. 15 squared is?
3.9.
What's 15 squared? 225. And then I suspected you
Oh.
subtracted.
Oh,
Two,
no.
okay, so
Something else.
225 minus 56.25. 168.8. And now we need the square root of that. Square root of 168.8.
12, 13. Rounded.
13.
Yeah, rounded.
Okay, let's go carry a couple decimals. So 12 point.
9, 5, 2, 3.
Okay, we'll stop at the 2. Ta-da! So then, now we can find the area of this triangle in here. So the area of this triangle is going to be 1/2 times 15 times 12.992. Remember that this is the base face of my shape.
97.4.
97.44. Okay. Phew. We found the area of the base. What's the lateral surface area of my pyramid? What's the formula for lateral surface area?
1/2 times the perimeter times the slant height.
Did you find it? It's here. It's right here. What's the perimeter of my shape? 45. What's the slant height? And when you multiply all that together, the lateral surface area is
450.
450 even? All right. Bless you. Now let's find this total surface area, which is the lateral surface area plus the area of the base. Do we have the area of the lateral surface area? Do we have the lateral surface area? Yes. Do we have the area of the base? Yes. Add them together and we get?
547.44.
She's fast, man. Feels all right? Yeah. And I know the section's tricky to look at the figures and know what you're trying to find, yes? Yeah. So I recommend grab some pencil colors or colored markers or highlighters and start highlighting different things that you see, okay? All right, there's 2 others here for you to practice with. Let's go to the back. We're doing real good, guys. Let's talk about cones for a second, because these are related to pyramids. In fact, they feel almost exactly like pyramids, except what shape is the base? It's a circle. All right, we've got the vertex again. That's a little piquito point on top. That's the vertex. El piquito aquí arriba. It's a vertex. I have a slant height. I have a slant height, which is, guys, I have a slant height, which is the height of it leaning like that, yes? Now, we can only really talk about these slant height things in terms of this right triangle. A right triangle has its axis, that is the line toward the center, being the same as its height, which means that that axis hit the circle right on its center. All right, let's get into our formulas. Not much more to say about cones. We have 2 formulas. The first one is pi r l. What is r?
Radius.
Yeah, the radius of the base. What was l?
Slant height.
Slant height. Total surface area. total surface area is pi r L plus pi r squared. Let's talk about this for a second though, because this should seem familiar. What does this look like? What does that piece look like? Yeah, this piece right here looks like the lateral surface area. And what does this piece look like? Not circumference.
Oh. Oh, yeah.
It gets confused with
The
circumference a
area,
lot.
the area.
Area of the circle, which, since the circle is the base, shh, ladies, we can say that it's capital B for base. It's the same thing as the total surface area from the other one. Yeah? Alright. So then, let's do it. Let's look at number 5. I'm moving slow because I know I got someone still writing. Yes? Okay. Alright, so number 5. Alright. Let's write our formulas so we can see what we need to find. What's the formula for lateral surface area?
Pi r
Pi r L. What's the formula for total surface area?
L plus P.
Okay, we could do L plus B. Let me go ahead and use the more extended version. I know it looks longer to handle, but let me show you how simple it can be if we leave it like this, okay? Alright. Pi is just a number, so I'm going to leave the symbol there. I'm going to replace R with the radius. What's the radius? What's the radius? Yeah, here it is. There's the radius. Bless you. This is a capital L, this is a lowercase. Here? Also lowercase l. So that L slant height is this one. Do I know the measure of that line? No, I do not know the measure of that line. But what kind of shape is right here?
Triangle.
What kind of triangle?
Right
A right triangle. And when I know two sides of a right triangle, what can I use to help me find the measure of the third? The what? The Pythagorean Theorem. A squared plus B squared equals C squared. One of the legs is A, the other one is B.
It's 15.
The hypotenuse is C. When you solve that down, you find the hypotenuse was 15. I agree with her, and I will confirm it because I've got my triples memorized. Ladies, please stay focused. Thank you very much. So my slant height is 15. What is the lateral surface area of this cone?
424.115 or 1.
Okay. Now let's get the total surface area. I left the total surface area as this really ugly equation because I already know the radius and I already found the slant height. And now I can just throw that in my calculator and be done. Total surface area of a cone is, of this cone,
678.584.
well, hurry. That's it. Think you can do these on your own? You shook your head. Tell me why. Where would you get stuck? Okay, which one? Okay, let me back up. How does this formula? Is that okay? All right. Finding the radius, is that okay? Good. Finding the slant height? No. Are you okay with what the slant height is? Yes, so you're feeling comfortable that it's that line? The one that I marked blue?
Yeah.
Okay. So what I did was I thought of that triangle I took it out of the cone. And I said, this is the height, which is right here. Here's the radius. And this was my slant height that I didn't know. And then I plugged those in the Pythagorean theorem. The only one that's important for you to get in the right spot is going to be the hypotenuse, which is our slant height. Do you feel comfortable following what I did here? Okay, so from here I did 9 squared. In your calculator, do 9 squared. Okay, and then in your calculator, do 12 squared. Add those together. And then take the square root of that. You took the square root of 225? Yeah, because you told me 81 plus 144. And then you said 81 plus 144 is 225. You took the square root of 225? And you got 5 something? Okay. I want to go take a look at your calculator just to see what's going on, because that seems weird. All right, I think everyone else is feeling mostly comfortable with this. Just going to quick read around the room. Yeah? All right, thank you very much.